Hello guys, and welcome to this live programming course where we will be learning how to make a video game on blockchain. This will be fun, so let's get started. So the first thing we will need is a test RPC. We will need Web3.js version 1.0, so make sure that you are using version 1.0 at least. And I will have a Web3.js documentation open, so because it's new, so I will need to check it regularly, and we will use that in order to build our contract and get the ABI and the binary. So let's get started. I will create a directory for our project. Make directory blockchain game. Cd blockchain game, npm init y, npm web3. Okay, npm e. We also need express. What do we need else? I think that's all. Okay, we'll open Atom there, and we will put it there. Let's create a app.js folder, file, package.json. I need a script. Start node app.js. Okay, cool. Now let's just test our Web3.js without any server first to make sure that everything works, and then we will put it in a server and wrap it in a web API. Then only we'll program our game, and our game will be programmed on Construct 2. We could use a real JavaScript library to program a game, but that's not the point. It will take like ages to do something. So yeah, I will also post the Construct 2 like JavaScript code on GitHub, so you will be able to use it even if you don't have Windows, because in order to use Construct 2 you need to have Windows. So Web3 require Web3 const. Oh, we also need to fire the test RPC. So once it's installed globally, you can just do test RPC. All right, we'll keep it there, and maybe new Web3. The test RPC is on localhost 8545. So we'll run it. Cool. No errors. So let's get the a list of accounts to see if everything works. So Web3 at get accounts, and let's use a promise. Then console log e. Okay, cool. It's working. We are connected to our blockchain. Now let's actually create a contract. Pragma solidity. We'll create just a contract to test our getter and our setter, so we are sure that everything works. grid is equal a new grid. So our contract is deployed. Let's quickly test it. I mean, now it's deployed. So hello everyone. Hey, hey. Maybe I'll wrap it. Cool. Now we need to get the information. Oh, I hate their new here. So we need that. Although, yeah, we just need that for the moment. And the Web3 API actually changed, so there will be some changes to make. Okay, so contract is equal to Web3 add an contract with a capital letter. It's a new API, and you have to do new. And the arguments to include is first the ABI, so we'll get the ABI right. And there's a formatting error. I mean, it's atom error. The code is correct. And this is cool. We got the ABI. Now we provide an object where we provide from data and gas, and we need to replace that. I don't want to. Yeah, let's just copy a static address. Where is our... okay, here it is. Copy. Cool. We don't need the callback here. The API changed, and we can get rid of that. Right. I'll put it here. I think that's all. We just need to... I just want to put it... anyway, no, it's not a problem. So I think that everything is okay. So now we will deploy the contract. Contract.deploy and send. I think that's how it worked. npm start. Cool. And we can see that the contract has been deployed because on the test RPC we have this transaction created at and the address. It's the address where the contract actually lives, and we can copy it. Do not press Ctrl C. If you press Ctrl C, you will kill the test RPC and you will need to restart it again, and since it's in memory, nothing is saved, so you will lose everything. You will need to redeploy the contract. So now we don't need that. We will comment out that. Just paste the address here. Yeah, maybe just reuse the code. So we need just to provide the address of the contract after the ABI. We can get rid of that, and now the contract will be pointing at the contract already available on the blockchain, so we can just do something like contract get string call, and it will be a promise, so console log and normally if we didn't make any mistake it will work. Oh yeah, there's no such function as getString. It was what the function name? It was getGreet, I think, right? GetGreet. Cool. So let's just use that here. And where's our terminal? GetGreet is not a function. Oh yeah, it's methods. contract.methods.getGrid.call. Yes, hello everyone. So we have a getter. Now let's try a setter. So let's comment this out and transform that in a setter. A getter you call it with call. A setter you call it with send. And you provide the argument. No, actually you provide the argument in the function name setGrid. And you provide the object that will say like how much ether you want to send, and if you want to send some, and from which address you are sending the transaction. For the getter you don't really call, since everyone can call it, no matter who is calling it. But a setter is important since you will pay a fee for the transaction you are doing. So let's just say it. The new string would be I am a new setter, and we are going to send from this address, from the first address. Okay, we got a transaction received, and now if we fire the getter again, the value changed. So we have everything we need. We have a setter working, we have a getter working, and yeah. Now what we are going to do is that we are going to create a new contract for our game and put it in a API. So let's do it. Okay, so let's create a contract. But before creating a contract, let's think about the game we are going to do. Let's use something simple, like a very simple version of Snake, where you have an object you move on the screen, and every time you actually eating something, it will send a request to the server, and the server will send a request to a blockchain saying, hey, this player got a new point, and this will add the points on the blockchain, right? So let's create a contract like that, and let's name it. I mean, that the naming is not important. Let's just use a variable called points 0 by default, and we'll have a function called add point. Something very simple. We don't want to make something complicated. If not, it will take 3-4 hours to program. I don't want to do that. Add points, and yeah, let's provide the points. So this is a setter, so points plus equal, maybe make it bigger so you guys can see. Points plus equal points, add points. What else? Get points for the getter. Really something simple. Oh, come on, what's happening? Where is my... Oh god, I think I'm in insert. Where's insert? Oh, cool. Constant returns uint, since we are returning an inside integer. Come on, what is this? I hate the new UI. I just hate it. It's impossible. Get points. I should use truffle. The next time I will use truffle, because this is horrible. Cool. Now we can add points where when our snake actually, or character, will eat the apples or whatever, we should be able to render the amount of points that the character has. And I think that's it for now. We don't need to make it complicated. It's already complicated. So we'll test the contract. Oh, come on. Okay, so we have 0 points, so if we add 50 points, we have 50. Cool. So now we are going to details. Okay, we've got it. So now let's wrap it in a API. Think of it how you would actually contact to it from a game using a AJAX request, for instance. We won't make it more complicated than that, not using WebSockets or something like that, just using simple AJAX requests. So yeah, let's create a server with Express. And we will also need something else with Express, since we are going to contact our server from another browser. We will need a cross-origin framework, so just npm e course. Cool. So const express. You want to make it bigger? Okay. Require express const app express const course require course, and I think that you should be using like app.use course. Actually, I'll check it because course node. Yeah, that's okay. Course, okay. Okay, cool. So we need to call it here, and then we'll create a route. It will be only a pure API server, so we will use add points, rec res next, since we are using a middleware, and in this route we will add the points on the in the smart contracts, and in this route we are going to render the points, so get points. Okay, so let's do it. So okay, so you can automate a lot of things. You can automate contract deployment, a lot of things, but now we will just assume that we already had the contract deployed on the blockchain when we will do the API calls. So just to keep it simple, because it can be complex very quickly. So let's just deploy the contract. The new contract will come in this out. Actually, don't need that. Let's where's our browser? So we need the ABI, the new ABI, and no. Okay, we've got the new ABI. We need the new bytecode, and we don't have an address yet. Actually, no, it's okay. So we need the new bytecode. Okay, seems to work. And let's deploy the contract. Hopefully we won't get any errors. And now let's just comment this out. npm start. Cool, the contract is deployed. We don't actually need the deployment logic, but we will need some other stuff. So let's comment this yeah. We will need We'll need that actually. And we have the address of the contract. This is good. And let's just test it. Let's just do contract methods get points. I think it's get points. Call, then console log e. So let's see if this works. Okay, it works. So now we have our contract, and it can be a const. We don't really care. We won't change it. And we can already do the get points route. We can just copy it there, and in the promise just do res.send, and it will be e. So we already had this route ready. That means that when the game will do the request to know how much points the player has, we can return the points. Now with the add points logic, we can just take this line and add it there, and just change the logic here. It's set points, and we will need to pass a parameter, right? Yeah. So if I'm not mistaken, it's const points is equal reg.query.points. We will console log that. Points. Player sent points, and we'll need to parse it to integer, although it's not very important. It can receive strings, so it's not a problem. Set points, and we'll pass the points argument, and it's a send, and from it will be this, right? From, and then completed, points added. Let's just send something, points added. Okay, cool. Now we have a very basic API that adds points and gets the points, right? We already have our contract deployed, and yeah, we don't even, yeah, we actually need that, sorry. So the only remaining piece is app.listen, so we can actually fire the server. So now it's ready. Now let's talk about the game. We are good there with Linux. I'm using Construct 2. And Construct 2 is basically an engine that allows you to make games without coding. I mean, it's a lot like moving events. So basically you have this event sheet where you can... Oh, it's actually appearing on my other screen. When stuff is appearing, and you can program it in a event-driven way. So yeah, let's create a sprite, and it will be, oh my god, everything is appearing on the other screen. So this will be our player. Yeah. Drawing skills level 100. This will be our player. He's very happy because he will get some points. Okay, cool. maybe a bit smaller. Let's add some controls to it. Actually, we'll put it in the middle of the screen. And it's been a while I didn't use that game, but let me see. 8 direction. I think that's actually how it works. Not sure if it will work. So if I use the arrows, oh, actually, it actually works. Well, we will leave it that way. I don't want to lose too much time on the game. And what we are going to do is that we are going to spawn some, like every X seconds, we are going to spawn some apples or some things that the player needs to gather, right? And let's actually create it. So new type, and that will be another sprite. And let me get where's the color? Somewhere should be. Oh no, what am I doing? Yeah, I don't know where the color is. Fill. Yeah, basically a piece of cake. So let's draw an apple. Oh, here's the color. Apple. Well, it doesn't really look like an apple. Oh, okay. I can do better, but yeah, whatever. So we have an apple. Actually, there's a fill tool here. So cool. Yeah, so this is my apple, and I will just put it there. So basically we will create a logic that says that every like, I don't know, 6 seconds, oh my god, everything is appearing on the other screen. It's not convenient. Every 6 seconds we will spawn actually, I think spawn, create object. We can choose the object to create, sprite, and layer. Doesn't matter now. The X coordinate. So window height or layer width, layer height. Okay, so yeah, I think we should use a window because the layer is basically all that white stuff, but the window is there. So we should spawn the object at random. There, I forgot how to do the random, so create object like this apple and random range. Okay, so it's from 0 to what's the window size? Let's put it to 10 for a moment. So the window, okay, 840 and 480 and 854. Sorry, normally it's my sleep time now. I'm actually sleeping during the night, working during the night and sleeping during the day. But I was really excited by the idea of making a video game, so I couldn't wait. Okay, so let's just do a random. So the height, it's actually 8. Let's put it a bit lower, and this is the weight. Yeah, this is the width, and the height will be 840, and would put it a bit. So let's run the game to see how it works. It doesn't really work that well. I'm wondering why. Let's create a layer. Maybe it's because of the layer. So layer 1, and let's actually wait a bit, right? Every 2 seconds we will create something. Ah, cool. We have our stuff. So the player will be moving around, and we'll try to collect those apples. So the apples are appearing randomly. Now we will just modify it, put it to 6, and the first apple will be actually there, and it will use this apple as a prototype. So every other apple will be of the same size. So now we need another logic saying that when the player will collide with the apple, we will delete the apple and call the Ajax function, saying to a blockchain, hey, I just ate an apple. And we should have a global variable as well for the score. So we'll create a global variable, we'll call it score, and by default it will be 0. Actually, let's put it as text. By default it's 0. And no, actually, it will be a number, and it's what was the keyword? Let me think. On collision with another object, and we will choose the apple. When it does happen, the apple needs to be destroyed, and I think by default it is targeting the apple I'm using there as an example, and then I send a Ajax request, and we just need to add the Ajax object here, I guess. So a Ajax here. So when it's happening, we will request URL, which is a GET request, and the tag will be add points. And we will send it to localhost 3000, and since it's a get request, points is equal to, oh god, oh, let's say that every apple is like 50 points, so by default it will be 50, right? Cool. So, and we will say that when it's done, when the request is completed, and we tagged it as a add points request, then we will update the score, right? No, then we will actually get the new score, Ajax request, and get points, we'll call it, localhost 3000, get points. I think that's all. Oh, yeah, here. I forgot the route name. Add points. Right. Yeah. Okay, I think we've got it. So, and when the get points will be completed, on completed get points, I want the score to be updated. And set value of score to ajax.last data. And can we actually transfer it to integer? Oh, we can. Nice. It's actually not set score, it's actually add. So add to score. Oh, nice, it remembers what I put. Cool. So if everything works correctly, we should be able to move our player, and when the player collides with an apple and the apple will be destroyed, we will send a request to the server saying that, hey, we destroyed an apple and we want to add 50 points, right? The server will contact the blockchain saying the blockchain to contact the smart contract and adding, in order to add the points, right? And once and it will return back the request of the AJAX request. So once we have this AJAX request returned, once it's completed, we can actually send another request to get the new points from the server. Actually, it's not mandatory, but I just want to do it. We can already update the score immediately there, like adding 50 points, but I choose to do it that way. So we'll fire the get points stuff. So once the get points is completed, we will update the score. And we should actually, yeah. Oh, sorry, it's not add. What I'm doing? It's like asleep. It's set. My first thing was correct. So because we are getting the total score from the blockchain anyway, and right, I think it's working. So now we will save it and export it to a HTML website, and we will call it desktop blockchain game. Okay, we'll close that because probably we'll need to modify some stuff. So we have the folder, and we will reopen our window there. Hola. So I want to just copy the file. Okay. Please, Linux, show me the file manager. Okay, cool. So, oh no, why is it? Come on, copy. Okay, whatever. And blockchain game. Okay, so if everything is correct, it should be calling our server, right? So let's open the index.html. I know. And let's try it. Get request. We didn't get an answer. Let's check our server Oh yeah, we didn't start it. Yeah, we didn't start the server. It's so silly. Oh my god. npm start. So let's reload it. I'm getting confused with all that stuff. Okay, cool. Let's get started. Let's see if it works. Oh, okay, we have an error here. What is the error? Player sent 50. Contract method set point is not a function. How did we call the function? I'm always doing the same mistake. What's add points, get points, set point? Oh, add points instead of set points. I'm so silly. And it's add points, get points, add points, get points. I think it's good. Where is our terminal? Our Mac is so much better for that, but I don't have a Mac anymore. npm start. Cool. Now let's restart our game, our so-called game, and let's see if we can get a 200 status. Oh, cool, we got it. And you see, the contract was updated with the transaction and with the call. So yeah, cool. Now we just need to render the score. I forgot about that. So let's get back to our construct and let's create a text object there, and and for that, like every tick, every frame, every tick, where's tick? Every tick, the text would be set. Oh, why is not working? Set text. Set text to score string. Let's convert that to a string and add it to your score like that. Doesn't work. Why? Oh, okay. Interesting. So by default it will be 0, right? Okay, cool. Let's export it again. Blockchain game. It should replace the all the files. Cool. Now let's re-import it again, please. Mac. Oh god, it's horrible. Move to trash. Cool. Now let's try it again and index.html. I want to get my network console. Let's try it. What? That was odd. The first was odd. It's like it fired it 3 times. Whoa. What's happening the first time? Interesting. Oh, I think I know what's happening. But it can be so silly. Wait, we will restart the... So here we have it, and we have a basic working game, and yeah, we use blockchain to keep track of the of the score, we use a smart contract that will add the scores and that will display the scores, and we've made a UI for the game in Construct 2, which is free, by the way. It is limited by free. But yeah, thank you for watching. I hope you enjoyed it. Sorry if it was a bit messy, but I was also discovering a bit the idea, because I just had it and I just wanted to try, and I wondered why not making a live streaming for that. So that's cool. Thank you, and see you in the next video.